and get ready to download some stuff, because you might as well be downloading it while I'm talking. And if you don't have a computer, I recommend getting close to somebody that has one, because this is not 2 hours of talking, not at all. I'll only have maybe half an hour, 45 minutes of talking, and then people will be doing all this stuff. And there's a lot of fun to be had. You ready? Okay, it's going good. Thank you. All right. So if you got a computer, the first thing you do is go to samsclass.info, right here. That's where all my stuff is. And then go down here to Security Auditing Android Apps. And click on that. And when you get there, you'll find this page. And if you scroll down a bit, there are projects. And the most important thing to get started on is one of these, either Ubuntu, Mac, or Windows, because the Mac, all of these involve fairly large downloads, so you might as well be doing them while I'm talking.
What is the networking system?
The network here is C3. Yeah, C3 Public should work. Let me see what I'm on. Yeah, C3 Public seems to work fine. Good. All right. So I hope that'll get most people started downloading stuff. And let me start with the slides here. I got a few of them anyway. All right, so I'm Sam Bowne from San Francisco, and I originally was going to just talk about Android apps, but I recently found out how to do iOS apps too, and it is a very rich field because apps are complete garbage, especially Android apps. In my test, 70% of Android apps are vulnerable, and maybe 15% of iOS apps in very obvious, simple ways. You do not need to be a genius to find enormous holes in them. I'm sure they have a lot more holes than only smarter people can find, but even very simple tests are enough to find interesting things. This is like back in the 90s when hacking was easy. So OWASP, as always, has been on the job, and they have made the mobile top 10 risks. And the ones we're going to check for here with the hands-on projects right here, because they're easy enough to do in just 2 hours, is lack of binary protections and insufficient transport layer protection. The most common vulnerability in Android apps is this one, lack of binary protections, which means you can take apart an Android app and see the Smalley code, which is more or less easy to read source code, and you can modify it and make a modified app. And that is a really bad idea, and it is completely unnecessary. It is entirely possible to have binary protections on your app so that when it starts, it checks the signature, it checks hashes and checksums. You can obfuscate the code and make it difficult for someone to modify it and have the modified version run, or you could do what the NFL did. Now, the NFL got busted for an insecure app, and they modified their server, their app, and their server, so that when their app starts, the very first thing it does is contact the server, and the server checks the app to see if it has been altered at all. And if it has, you can't do anything. It just says you must update your app. Wait while it updates. So we know a lot of ways to prevent people from modifying apps, although none of them are perfect. And people typically don't. The next most common thing, I think, is insufficient transport layer protection. Some apps actually send plain text up, more than you would expect, although that's not too common because most people are smart enough to know that's a terrible idea. But an enormous number of them break TLS, especially in Android. They have the ability to connect over port 443 to an SSL server, but they do not verify anything about the certificates. You can just send them a fake certificate and they fall for it. This is extremely common and quite disturbing. So here's number 10, adding is the most common one. Anyway, Android has the largest market share, it's cheapest, and it's got a philosophy of being open and letting people install apps from everywhere. And all of this, of course, makes it much more vulnerable than iOS, and the apps are easily messed with. And they're written pretty badly in the first place. People take the same philosophy, my opinion, without knowing exactly why developers do this, is they learn to write iOS apps and then they apply the same philosophy to writing Android apps. And this is like practicing in a safe playground and then playing in the street with the same procedures. Because Android doesn't protect you at all, and iOS protects you quite a bit. Anyway, so you have to sign apps. Every app has to be signed, but it doesn't have to be signed with real signature that goes to a public certificate authority. You can just make a self-signature, and it will fall for it. So I'm not quite sure what the point of that is. Also, Google does not force you to install everything from Google Play, although they are moving closer and closer to doing this. When they started, they were more open, and as time passes, they're getting more and more strict. And of course, if you're loading apps from strange places, company websites and email and such, then who knows what you're getting. Anyway, Android Debug Bridge is your main tool here, ADB. You can connect to a real Android device through a USB cable, or you can connect to a simulated device running in a virtual machine or over TCP, and then you can control the Android device with ADB command line tools, which is very nice. You can push a file to the device. You can pull files from the device, which is very nice. So anything running on your phone or tablet, you can pull it down, get this file, and decompile it, decode it, and see what it is. You can view the log, which we're going to do quite a bit of. You can install things, and you can start a shell and just have a command prompt on your Android device and gives you commands there. So static analysis is typically fairly difficult for Windows apps because you have to use IDA Pro or something and read machine code, things compiled from C. But Android is not that way at all. Things start in Java, and they compile down to Smalley, which is Dalvik bytecode, and the Smalley is very easy to read. In fact, it's not much harder than Java. So every app basically comes with the source code included, as you're going to see. So you can just decompile it with a variety of tools. APK tool is the one I like. APK tool is just a Java tool on by Mac, and you can decode an app. You take apart an APK file, it's just a container like a zip file, and you get a ton of files. So this is the TD Ameritrade app. Now, when I got started looking at the security of apps, I just went through the top 10 banks, and then the top 10 stockbrokers, and the top 10 insurance companies. And I found that 70% of all of them were vulnerable. And I contacted them all, and I've been sort of fighting with them ever since February about this, saying, you guys should fix your stuff. And some of them have, in fact, fixed it. Now, quite a few of them don't talk to me and ignore everything I say, but none of them have told me this doesn't matter. They've all agreed they have to fix it. All the ones that will talk to me. Anyway, so if you take apart TD Ameritrade, this is what you see. You get a whole lot of folders, and down here you get subfolders and subfolders, and then you get the Smalley routines, and they just have things like Cache Manager, Base, Account Manager, Consumer API. Notice how all this is completely readable. This is, of course, a terrible idea and completely unnecessary. You do not need to distribute to customers an app that has readable variable names and method names and file names in it. They should have all been obfuscated, but they aren't. Now, Android Studio, which you're downloading and installing if you got started there, includes a free obfuscator, called ProGuard. This thing is completely worthless. And you can see what it does. The Bank of America is protected with ProGuard. So it has all these just as readable as ever, but a lot of these are changed into A, B, and C. But the important ones, the ones that are referred to from elsewhere, are left with their original name, activities. Like here, they've changed a bunch of things to A, B, and B, Z, and C, but business credit card details activity is still readable. So this is like a guard that closes half the doors in your building. I don't even know why anybody bothers using this thing at all. It doesn't slow me down at all, Trojaning these apps. And there's the difference between Java and Smalley code. This is the Java up here that's going to put username and password into variables, and here's what it looks like doing it in Smalley. It defines parameters, username, and password. It's a little messed up, but it's not really much harder to read than Java, and it's not much harder to change than Java. Yeah?
Sam, would you go back to the download link?
Yeah. You should start at samsclass.info. Yep. And then click on Security Auditing, Android apps there. And that will get you, yeah, this is a good thing to do. That'll get you to here. And down here are the instructions for Ubuntu or Windows. Here, let me go around and take a look. See if everybody should get started downloading that stuff. Yeah, click on that. Then scroll down a little bit, and you'll see there. Do one of those two, whichever one's appropriate for your OS. Have you got it downloading? 2 hours.
8.7, right? You have a Mac. Is that what others said?
Huh, he was getting it. Well, that's not good. Have you started downloading it?
I tried, and then it's just actually complicated.
It downloaded for you, right? You had like 8 minutes. He's getting 2 hours over there.
Yeah, but I'm done.
You're done.
But I'm on my...
Oh, you're going through your own network. Well, here, let me get a USB. Let's try moving it around that way. We have so many Windows users. All right. All right. Well, you get the Windows Android Studio. Please put it on each. Appreciate it. All right. Because the network is not fast enough. Okay. All right. Let me try this again. All right, so we're going to have some USB drives moving around with the copies of the Windows Android Studio on them. All right, let me go back to this. Let me know if you have troubles, because the main point here is for you to do the hands-on, so it's good to get things started. Anyway, so you can modify your Smalley code very easily, and I learned about this from a talk called Dancing with Dalvik that a guy's been doing at quite a few of these cons, showing how he modified games on Android for his children. Anyway, you build an app the same way you took it apart with the APK tool, and then you have to sign it, but you can just sign it with a signature you created yourself without paying anybody anything. And then you can install the modified app. You can monitor the log inside Android Studio with this Android device monitor tool, but that's not really the best thing to do. Usually the command line tool is better, because then it's very easy to use grep to filter it. And the log is far more interesting than you might think it would be. The log, by the way, is no place for any sensitive data, because every app on the device can read the log. So anyone can steal it and send it anywhere. All right, so the M10 vulnerability I was talking about, you can do anything you want. Modifying the app, you can go look in there and find the encryption code and keys, and you can add Trojans that steal things, which is mostly what I've been doing. I've been doing quite a lot of that. And here's that talk I mentioned from Thomas Richards, Dancing with Dalvik, that showed me how easy this was. When I saw how easy it was to write Dalvik Trojans, it really got my attention. So let's do Charles Schwab. Now, you are going to do this. Let me point out, so here's, after you get set up here with this one, you can then Trojan the Charles Schwab app. And I'm going to talk about it instead of doing it entirely live here, because I'm hoping you people will do it. So you download Schwab into your device. Now what you'll do here, after you get Android Studio, you'll also download Genymotion. And even if you haven't got Android Studio, you might go ahead and start downloading Genymotion there, because the C3 network's probably fast enough for that. Genymotion is the best Android emulator by far. The others are pretty sad. This one gives you a nice emulated Android device you can play with easily on your machine here. And you can, if you follow the instructions there, you'll find you can get the Play Store working on Genymotion. You can get genuine apps right from the Play Store in your emulator. So I'll show you what that Trojan Charles Schwab does in a minute. But here's the point. You get the Charles Schwab app, then you just, these ADB commands are enormously useful. Here you can list all the packages on your device, which is going to be a long list. Then you can grep it for something. I just looked for some words in Charles Schwab, and I found it. It's com.schwab.mobile. You can usually guess some of the words in the name of it. If all that fails, you can actually launch it and list all the running processes to find the app. I had to do that for some of them that had very strange names. Then you find the path to it with ADB shell PM path, and then you just pull it, and here you get the APK file right off the Android device. So this is about 7 megs. Now, you take it apart with APK tool to make this pile of files. Here's what the Charles Schwab looks like when you take it apart. It's got many, many folders, and you can notice, again, there's no obfuscation here. All this stuff is readable. It's a little small here, but it's not just A, B, and C like it would be if they'd used ProGuard, or something better if they'd used a more expensive, better obfuscator like -O. And if you want to find anything to attack, you can just grep for it. And I looked for username. Password is good, but when you get too many hits for password, you can try username. And if you look in the projects, I have my 5 or 6 words I like to look for. And in username, one of the places it appears is in something called Session Management Service.smalley in a directory, comma Schwab Mobile Services Session. That's the one. All I do is try a few of these until I find one that makes it easy to steal the username and password, or credit card number, or something else. And in the Charles Schwab app, I found this method called perform login, and it has parameters called username and password. So that's pretty easy. And so all you have to do is steal that username and password. Now, what I really wanted to do, of course, when I first started doing this, was send them up to Pastebin. But it turns out that opening a network socket and sending network traffic out in Smalley is not easy. And even if you try to create the Smalley code by writing it in Java and compiling it to Smalley, it's still not easy because it calls libraries. And then you have to figure out how to add additional libraries to your Trojans. And I finally said, to hell with it. I'm just going to put it in a log, and I'm going to contact all these financial companies and see if that's enough to convince them this is unsafe. And apparently it is. So I'm not really trying to steal passwords from people. I'm trying to make a proof of concept sufficient to convince these guys to fix their code. And this seems to be good enough for that. So if you use this invoke static command, you can put something in the log this way. And the only way I know how to use the log is to send 2 string variables here. One is the name of the entry, and the other is the value of the entry. There are probably other ways to put things in the log, but that's the one I know. So the only consideration here is that whatever you're putting in there has to be a string. In this case, username and password are already strings, so it's very easy. All you have to do is make the string you want, send V0 and P2, so you say Trojan stealing username, and this will say Trojan stealing password. That's all you have to do to make the simplest kind of Trojan. And there's 4 different kinds I'll show you here. Then you recompile it and sign it. By the way, when you take apart apps with APK Tool and put them back together with APK Tool, you often see a screen full of errors, and it never seems to make any difference. Very frequently, it will often tell me there's a problem with all the pings, and yet when I run the modified app, all the images are there. So I don't know what all these error messages mean. They seem to not mean anything. So let me show you the Charles Schwab one running. I can show you the 4 kinds of Trojans here. So here is the log. Now I'll show you how I did that. This is just the only somewhat irritating trick is that you have to find where your SDK tools are. They're different in different locations for each operating system. But then you just run adb logcat, and this shows me what's happening in my Android device. So if I bring up my Android device, I think it looks right back there. Yeah, good. Thank you. All right. So these are Trojan apps I put on here. At least the first few are for demonstration. So if I launch the Charles Schwab app, you can watch what it does over here. So it's launching, and these are the actual log entries made by the operating system. So it comes up, shows me something about the stocks, and over here I have a button I can click that goes to a login button. So now I can log in. It's going to be CCC user and CCC password. And when I log in, right there, stealing username, stealing password. That's the point. The modified app steals it out of the code, not going to do anything with it. So this shows we're in trouble. Now, I found this is a fairly common type of app that just puts the username and password right there in a variable you can easily copy, but there are others. And the Bank Corp, for example, and these are all top 10. This is a Trojan version of the Bank Corp, and you'll see what this one does. When I go to user ID and I type in 1, 2, 3, see, I wasn't able to, it doesn't put the variable right in one string field. It puts them character by character with a thing called Secure UI. It grabs the keys one by one and builds them, but I'm still getting them. I have to steal them one, two as you type them in. So here's my username. Here's my password. So, I'm still getting it. But it's another kind. You have to basically catch it with a keylogger. Is how it looks like. And there's another one is capital 1. And here comes capital 1. Okay. and a capital 1, and go to user ID. And here, if I put in A, B, C, D, I'm getting numbers out. Now, these numbers look like ASCII, but they aren't ASCII. That's A, B, C, D, and here's 1, 2, 3, 4. They are a crazy thing called Android key codes, which Google did document on a page that is very inconvenient to use, but they are kind of like ASCII, and they can include ones for shift and other keys you might hit. But the point is, you are getting the keystrokes one by one like a keylogger, so you can still steal the password out of it. And there's another type, which I found, and which is SunTrust is an example of this. SunTrust is not one of the top 10 banks, and I wasn't going to test it, but after I started putting out some information about this stuff on Twitter back in February, someone contacted me and said, "Did you test SunTrust?" And I thought he was a SunTrust employee in the security department. So I went and tested him, and then I found out he was just a customer. I said, well, but it turns out SunTrust is a very big bank. Their Android app has more downloads than some of the top 10 banks. So it's not unimportant to test. And the SunTrust did show me different kind of Trojans. So if I put Sun user and Sun password here, and then sign in. Good. Thank you. Anybody else need the Windows? All right. Anyway, so if I sign in here, you'll see I'll get a pile of junk here. And what's going on here is I wasn't able to catch the keystrokes, and I wasn't able to find a variable that contained the username and password, but I was able to find the routine that made the parameters that are sent out to the web in HTTPS. And so every parameter, name, value, pair, is sent out here, and one of them is the password, and one of them is the username. May have to go up a little more to find it. Yep, there it is. Sun user is the user ID, and password is SunPass. So I was able to get it, but that's why it's long. You see every parameter that's being sent out. So I've Trojaned the routine that creates the network traffic. Anyway, that's fun stuff there. And let me go back to here. All right, yes, we saw them. That's the one that builds it one by one. That's got those crazy key codes, and that's SunTrust. Now, TradeKing was very interesting. I found the same kind of problem with TradeKing. I want to stock trading apps. And then when I tested it again later, they had actually fixed it. And what happens now is when you launch it, it shuts down with this verifier, rejecting the class. And the verifier catches exactly the routine where I put the Trojan. Now, I hope if any of you are Android developers, they can teach me what that verifier thing means. I would like to know. I thought it was something they added to verify the code, but I Googled for it, and a lot of people say that happens when you just have too many variables in routine or something, but if I change anything about the SunTrust app, it immediately fails in verifying, and it fails right where I changed it. So I don't really know what it is, or how it works, or how to defeat it, and that would be the next thing. One common thing people worry about here is that if there's something inside the app verifying it, in principle, I could find that and turn it off. But it's certainly, you're raising the bar, which I think is all you ever do in security. No defense is ever perfect. You put in a defense and you scare away some of the attackers. Anyway, some people think this attack is not worth worrying about because you can trust Google to keep their store clean and everybody will install everything from the Google store. And Google's doing better than they used to, but certainly they have not always kept their store clean. And back in 2011, there were a lot of infected apps in the store. Another fun thing that happened around this time is there was a bank that got called from a customer. I downloaded your Android app and I'm having trouble. They said, Android app? We have an Android app? Since when? And that's a pretty good one. And that happened to Spirit Airline. I was testing all these Android apps and I found a Spirit Airline app that just sends your username and credit card and everything in plain text. And so I contacted the developer and said, this is crap. And I got no answer. So I contacted Spirit Airline and they said, app? We don't have any app. And I said, well, you seem to. And they didn't listen to me for a while, but then eventually it escalated up to where somebody finally did tell Google to take the app down, so I was glad to see that. But somebody called Convenient and Friendly Apps was writing apps for people, random people, and putting it in there and writing them very badly. Of course, if I get to be able to talk to an actual human at Spirit that knew something, I would say, why is your server accepting plain text data anyway? But I wasn't able to get that far with anybody up there. Anyway, so Google did clean up their stuff from the Droid Dream attack, and then they launched their application verification service, and they have Bouncer, but it's not very effective. This is the effectiveness of it at catching malware. Their thing is much worse than all the commercial Android antivirus products. Anyway, you can prevent this to some extent, and there are quite a few commercial packages you can buy that will break this stuff at various stages. like I say, ProGuard is pretty miserable. -O is a very powerful obfuscator, but ArcSan is the one that apparently is the best. I say apparently because they won't talk to me and they won't give me a free trial, so I can't test it. It's very expensive, but it claims that it puts many layers of verification and anti-reverse engineering through your code, so every part of it is checking the other part, and if somebody changes something, they would have to be very, very diligent to find all the checks and balances and break them all. So they claim this will make it so nobody can reverse engineer your app, and I recommend it. And here's what -O does, which I thought is very nice. Remember I showed you what ProGuard does, changes maybe 2/3 of the things to letters. This is what -O does. All these things are just eval A, eval CX, and all the variables are turned into garbage like this. This is really running through them, real encryption to scramble them. So that, now in principle, you could write a routine that would just print out every string variable and hunt for it until you find the password, and you could probably automate that process. But this would slow down attackers like me. You know, I would probably just give up and do something else if I had to dig through that junk. Although I should mention, in order to develop those keyloggers, I did automate this a little bit. I made a thing that I wrote a little Python script, maybe 10 lines, that would put a Trojan that just logged the module and line number of the start of every module. So when I got irritated hunting around for the password, I would just put that in and then start it running, and the log will be screaming by, and then I type in the letters and see what changes. I can see what modules are called for every keystroke. That helps me track it down for some of them. And I should mention Fidelity, the insurance company. I've been struggling with Fidelity for months. I tried again all day 2 days ago. I can't find the blinking password in Fidelity. I can get the Smalley code, I can recompile it and run a modified app. And even with every trick I know, I can't find the password. I've been hunting and hunting. And I can't make it run through a proxy either, which is what we're about to do. So I think they might have something smart, like certificate pinning. I'm really not sure. But I have no luck trojaning Fidelity, and I'm not sure if it's just that I'm stupid or if their app's actually protected. Anyway, yeah, that's one way to do it. Now, let's move on to the next vulnerability, which is one that gets people more excited, which is broken SSL. So Search tested this in 2014. Now, they built an automated tester. They built a thing like the Wi-Fi Pineapple, a Raspberry Pi-based device that would sit in the middle, intercept all the wireless traffic, and it would send out certificates that had a whole series of errors. Invalid date, invalid CA, wrong domain name. They had a whole series of things that can be wrong with the digital certificates to see if any of them would fool the device. And then they had a Android device, an emulator, and they made an automated thing that would launch the emulator and click on the first 3 buttons or something. So it would try to create some traffic, and then they'd see if any of the HTTPS traffic went through despite a bad certificate. And they'd flag apps. And as you see, they found 23,000 vulnerable apps, about 2 or 3% of all the apps they tested. And then they informed all these app developers, because in the info page of your app there is a developer email address. So they emailed them all and warned them about it. And what I wondered, when I looked at this 7 months later, is how many of them are still vulnerable, even though CERT warned them 7 months ago. And the answer is a lot of them. So I went here, and here's ones with 100 million downloads. Popular apps that are still vulnerable to SSL man-in-the-middle attacks. And that is very easy to test. Let me just show you some of this stuff. If you go here, and actually, there's something else even more fun to show you, which is not in my slides, but it is in the instructions here. All right. The easiest one is TD Ameritrade. TD Ameritrade, let me go to the list of vulnerable apps. Just a sec. All right. All right. So here's the various vulnerabilities. And here's the code modification vulnerabilities. So here they are. The green ones are ones that have fixed it. The other ones have not fixed it. So 3 of these have actually fixed their stuff. For this one, I think it's primarily because one of the students in my class at City College, his girlfriend is the security officer at Wells Fargo, so we were actually able to get through to somebody. One thing that really bothered me is none of these people have any security contact at all. They have no bug bounty, no vulnerability disclosure policy. You have no way to reach anybody. If you have something to tell them about security, they don't care, and there is no way to reach them. You just have to shoot randomly. Anyway, some of them have fixed their stuff. Charles Schwab is worth talking about. So I went to Charles Schwab. I did the same thing. I modified the app, found where I could put in a Trojan, and made a Trojan that would log the username and password, as you see. And then I wanted to tell Charles Schwab. So I found an email form, filled that out, and told them, you guys ought to fix your app, and it just bounces. An error occurred when sending the email. So I went and I wrote an email to them, security at Schwab, which is something Dan Kaminsky told me. He told me, oh, you don't have to struggle with all this nonsense. Everybody has security at domain these days. I found maybe 1% of people have security at domain, and Charles Schwab is not one of them. It just bounces. So that doesn't work either. Then I found a UK email contact form, which just seemed to work, but I was skeptical. No, then this also was broken. Then I found a website that told me I used that email and sent something that didn't bounce. And then I found a Get Human page that tells me never email Charles Schwab about anything. They don't read emails at all. You're totally wasting your time. And I was getting pretty fed up here, but I just want to mention I did something I've done several times with great success. When you get tired of all this nonsense, find the CEO on Twitter. I've done this several times. I did this with the Wall Street Journal and several other. You find a vulnerability, you get the CEO on Twitter, and if I found, I did not think this would work, but if I send a CEO an email like that, please follow me, they follow me. I thought they must be bothered by a lot of people, but apparently not. Of course, the problem with this is not subtle. It's pretty obvious what I have to say to somebody. And so people jump in the bandwagon like Swift on security, trying to help out, I guess. This is not very far from just full disclosure, but anyway. Then he followed me, and so I sent him the vulnerability here, and of course, then they didn't fix it. But at least then I could say I told somebody, wait 30 days, and then I give it to my students for homework and everything. Anyway, the one I wanted to show you now was TD Ameritrade. So TD Ameritrade is the stock trading app here. And they get a special color because this is the only company that actually got worse after I warned them. So here's the TD Ameritrade app the way it used to be. You go in here, you can log in and do something other with your stocks. And all you do is take that thing apart, go in here, and you'll find a parameter. Use your name and password, and you can just steal them with the same old kind of Trojan, and it works like a champ. So that's easy. And I notified them. But when I went back, I saw they had updated their app. And here's what and I took the app, I decompiled it, I Trojaned it, I looked for the username and password in the logs, and it was there twice. So after I notified them, they modified their app, and this is the genuine app, not modified. This is awesome. I've only seen this twice, and the other companies like vanished and taken their apps out of the store in shame. Let's get this thing to listen to me. Okay, that's the log. If you launch TD Ameritrade, that's why I put it in the project, because it's an easy one for you. Hey, do I not have TD Ameritrade? Hold on a minute. Well, that's irritating. Let me bring it down. There it is. And there it is. It is installed. All right. Well, I guess I can launch it from here. Okay. There we are. There's TD Ameritrade. Okay. I can log in. And my user ID is idiot. And my password is idiot password. And when you log in, it puts it right there. Idiot. So I didn't need to Trojan their app. They comes pre-Trojaned, and they added this. I went back and tested the earlier version. I didn't used to do this. So I don't know what's fallen off the bus up there. And but they're pretty far gone. All right. And another one worth mentioning is Geico. When I contacted Geico with this code modification vulnerability, I was surprised they actually have a good form here. They have a security form that asks if you're a security researcher. Let me see if I can get anything to come up here. There. Contact us by email. Thank you for writing us. Are you a security researcher? Proof of concept? All that. Wow, this is the first big financial company that is not completely in the Stone Ages, pretending they have no vulnerabilities. They actually have a form. You actually fill it out. Then a human will actually talk to you, and then they don't fix it. But still, and I talked to me, when he talked to him on the phone, I talked to them, and I said, why is this up there? And he said, because another researcher before you couldn't reach us and put us at number 20 on the top 20 the most least secure apps. So he put us at the bottom of the list, and that humiliated us, so we put up the form. And then, but what they have matured from pretending there are no security problems to admitting there are and having a form, but they have not matured to actually using the data from the form to do anything. Anyway, so that's the game there. That's why I think it is pretty shameful. If you find a problem with these big companies, they just don't care.
That happened week one. At the end of week one of my new job last summer.
Yeah.
I walked into where somebody was going to go to. The one table out here is advertising the security conference in Las Vegas.
Mm-hmm.
And there was a pen tester from LinkedIn that had tried contacting our company for 6 months.
Yes.
And finally sent an email to the CIO.
Yeah.
And when the CIO got it, immediately there were all heads turned. And it was a TLS and an Android app.
Good.
And it was fixed probably in 24 to 48 hours.
Well, I'm glad to hear it. That's one.
My question for you, when you contact somebody, do any of these companies, because if conversations probably exist that they want to send a cease and desist letter from the law side of things, but knowing that you do public speaking and stuff, they don't want the bad press of a company saying, stop pen testing our site or we're going to sue you type thing.
Well, I'm glad you brought that up. I did get in trouble back when I used to pen test websites. Okay. And then my lawyer told me that's illegal. Even if you go to a URL and you put an apostrophe at the end and see SQL error message, you've now broken the CFAA, which was news to me. But it says if you send a signal to a server and the result is you gain information you are not authorized to have, you've broken the law. So now I know they have a vulnerability, which I'm not authorized to know, and I did it by sending a signal to their server. But I'm not sending any signal to anything in the app. So he told me this app research is legal, and no one has attempted to punish me for this app research on the financial side. So I never got that answer. I wondered if that was going to happen. If they're going to say you have to take us off the page, you have to not tell anybody. But I didn't publish it publicly. I gave them time to respond. But even if I hadn't, I don't think I'd be breaking the law. However, when I found the HIPAA compliance, which is coming up, then a guy actually did call the college and tell them they had to fire me, and he's going to sue and everything to get me to shut up. So it's actually probably a good thing to forward on. Let me. But first I want to show you how the SSL phone works. This is actually very easy. So if you go into your Android device, you can set your device to use a proxy server. Now this, by the way, is the easiest and not a very perfect way to do this. But this is how you normally audit apps. If you just want to run a normal app like an app you designed and test it, one thing you might want to do is look at the network traffic. And the network traffic is probably HTTPS, and you want to look at it. So what you do is you run it through a proxy. Now you could use proxy developers for some reason like to use Charles. Pen testers like to use Burp. And for this purpose, they're about the same. So if I go here and look at my IP addresses, I've got 10.0.0.65. I think that might be the one to use. Let's see if that works. Just a sec. 10.0.0.65. 8080. All right. Now, that says an HTTP proxy, but it will work for HTTPS also in most cases. So now, if that's working, I will have traffic show up here in Burp when I use the internet here. So if I launch a browser, for example, yep, there we go. Wikipedia loads. So now I'm intercepting traffic. All right. Now, the reason this is working is because PortSwigger, Burp, is creating HTTPS certificates for every website I go to, signed by the Trusted Certificate Authority, PortSwigger. And in order to intercept traffic like that, I had to install the PortSwigger certificate in this device. And I'm going to, now a common mistake beginners make is they forget to install that port trigger certificate. And I'm going to create that here by removing it. Credential storage, trusted credentials, user has put in this thing called port trigger. I'm going to remove it. If I can figure out how. I think it was, there, clear credentials. Okay, if you remove all the credentials, now it doesn't trust it anymore. Now if I go here and I do something like click on a link, I'm going to get this warning. Now this is good. HTTPS is now broken. The certificates I'm getting are signed by Root Certificate Authority Port Trigger, and this thing is telling me correctly that it's no good. So any proper app will no longer work. And I realize this is a very simple poor man's way to do security auditing. I now have doing an HTTPS man-in-the-middle attack with one type of bad certificate, and all I have to do is load apps and see if they'll fall for it. And the answer is a lot of apps fall for it. This is a very easy way to do it. It is not as thorough as the cert test because some traffic does not follow this proxy, and there are some broken HTTPSs that do check the root certificate authority, but they forget to check something else, like the expiration date, and I won't catch them with this test, but I will catch quite a few of them. So let me go back to my slides here. So that's the simple SSL test. So here's PixArt, for example. If you load PixArt, the HTTPS goes right through, and you can just see the password down there, password and username. That's because they don't verify the certificate. And they've ignored search warning 7 months ago. InstaChat is the same. Down here, I got the username and the password. Just any data they send can be intercepted by the man in the middle. OkCupid actually fixed their stuff. I checked. And I think it was after I don't think I told them, I think it was after CERT told them they actually fixed it. But anyway, now it warns you. If the network appears to be unsafe, Safeway is still unsafe. They were warned months ago. So there's that list of 23,000 apps, and CERT just published a spreadsheet of all of them. So I started going through and sorting them, and I realized there's a bunch of medical apps in there. And one thing I found in the past is that if you tell people about security problems, only 20% of the companies will fix them. But if you tell people about HIPAA violations, they will usually do something right away, because that really scares them, and they usually have a HIPAA compliance office. So it seemed to me that if there's an app that sends medical data, is broken SSL, that violates HIPAA. And so I found 265 of them in the CERT list. And as I say, they have all been notified already, so I don't have to wait for responsible disclosure. CERT already disclosed them last year. So I checked them, and here's the law, as far as I could figure it out. Individually identifiable health information should be protected with reasonable safeguards, which it seems to me means you shouldn't use broken SSL, although it doesn't say that explicitly. And so I went through a lot of these. I went through the tests, and I found, maybe 10 or 15 of these that are still vulnerable, including some fairly big ones, GenieMD and Lowest Med. I published this list, and see, this began to get some attention because the previous one with the hundreds of thousands of apps actually hit Ars Technica. They actually published it. I said, I don't think there's a story here. I'm not doing anything new. But he said, there is a story, which is they ignored CERT, and 7 months later they're still vulnerable. So he put it up there, and that humiliated them, and quite a few of them fixed their stuff after they were mentioned in an article. And so this one here did not hit the main press, but I think they've been alerted to be sensitive because of that. So GenieMD immediately responded on Twitter, as soon as I put this out on Twitter, and said, we are not covered by HIPAA. We are not a covered entity, so it doesn't matter if you use broken HTTPS. And I said, well, guys, I'm not a lawyer. Maybe you're not covered, but why don't you fix your stuff anyway and then won't talk to me anymore? That's the end of that discussion. But Lowest Med is the one. I sent them an email to notify them, and I notified them on Twitter, I think. I'm not sure, another green. And they called the president of my college and said, you have to I'm going to sue the college unless you take this page down verbally. And then they sent me an email saying, these guys called, they're suing the college, what's wrong with you? They're used to this, by the way, at my college. This happens all the time. Like at least every semester, someone calls the college to scream and yell that I have to be fired and silenced immediately. They've gotten pretty used to it. So they sent me an email, and I said, give me the contact information. It was just a phone call, so I sent the guy an email and said, whatever you have to say, you got to talk to me because the college cannot take that down. I put that up, and if you want it down, you got to talk to me, and you got to talk in writing, and after I get it in writing, I'm going to show it to my lawyer, and we will craft a response. And suddenly, their tone changed completely. And the next one was a polite statement, not threatening to sue me, not threatening to fire me, saying, we feel we're not a covered entity for this reason and that reason. I said, well, that might be true, but I'm not taking the page down. So I'll put their comment up there. I haven't done it yet. But they say the patient is not a covered entity. So if you're the patient and you choose to do something like email in plain text your medical data, you have the right to do that. And therefore, they can write an app that the patient uses that does that without telling you, and it's okay. And I don't know if that's true or not, especially when you make appointments with a doctor and it goes in a database at that end and that data comes back to you. I don't know. But it's for lawyers to fight about whether it breaks the law or not. But I don't think it's a very good policy. And I must say, UCLA was warned 7 months ago. And when I contacted them again, last week, they responded immediately. So they just hadn't noticed the earlier one. So there's GenieMD, does the same thing, sends your username and password to log in and see medical data over broken HTTPS. And anyway, so I talked about the response. So you can test new apps. Now, I tested a whole bunch of more apps, but a lot of them are still waiting for the 30-day time period I've arbitrarily set for myself to time out. But one of them I was able to talk about because they fixed it very fast. This, I think, deserves an award for the fastest response. Blue Cross Blue Shield. Does anybody know anything about Blue Cross Blue Shield? I was amazed. When I just went to Android and looked at their apps, there are dozens of apps. Apparently, Blue Cross Blue Shield is not like a franchise where you all have to obey some rules. It's just sort of like a club where you join, put the logo on the door, and now you do anything you want. So there's a Blue Cross Blue Shield for the federal employees of the credit union in Maine. Every little district everywhere just writes their own app. They're not the same app. They're not the same servers. It's madness. So, of course, some of them are insecure. And Blue Cross Blue Shield of North Carolina was insecure. It sent the stuff with broken SSL. So I contacted them along with a bunch of others, and they fixed it immediately. But this one was pretty awesome. And this, by the way, is a fun thing to do with your Android apps. When you find it breaking SSL, look for the social media links. Because when you click on those, frequently what happens is, instead of launching the default browser, it continues to launch inside the app with their broken SSL. So not only does it leak the app's credentials, it leaks your Facebook, Twitter, and Gmail credentials. And I was pretty surprised. You know, if I was Google, I would not let people put apps in the store that leak Google credentials. It would seem to me like that might catch their attention.
They just had one of the largest medical data breaches in the history of the United States, probably about 6 months ago.
Which one was that?
Blue Cross Blue Shield.
Oh, yeah, it was. That's right. Yeah, but I think it got on their server. Yeah, but this is, of course...
I mean, so all these apps right here, all
Yeah.
these little statewide things all filter back up to the top.
Oh, they do. Okay, yeah.
So on the top is vulnerable.
Yep.
All that information from these, that's why they're responding so quickly right now, because they're here locally.
Yeah, but it was not the feds. It was a local branch I talked to, because the apps are written by every little local developer. And this local developer fixed it in 2 days. And the new version now has a security box that pops up correctly saying the connection is not secure, I'm not going to use it, which is very good. So I was very impressed. It only took them 2 days, so I was able to talk about it. Another thing that was fun is I was looking for insurance apps, and I found that AIG Insurance does not have an insurance app to manage your insurance. It has something called Mobile Guard, because if you insure your cell phone itself, you have to put this app on to get their insurance. It's a security product to track down your cell phone, locate it, and remote wipe it, and all that jazz. And I said, okay. So here's the AIG Mobile Guard. And this thing, the clip? No, I got it. Just prefer to hold it because I've used them before and it just scrapes and doesn't work very well. Anyway, the AIG Mobile Guard logs the PIN by default, just like that other one. You don't have to Trojan it. It comes pre-Trojaned, logging the PIN. And it has other entertaining features, like it stores all your data in plain text, your mother's maiden name, your PIN and everything on the device, so people get that when they steal it. And when I contacted the company that made this, they just took it out. They took it out of the store. They have a bunch of these. Mobile Superhero does the same thing. Virgin Mobile Rescue, Rebound, Mobile Security. There's a whole bunch of them that do the same thing. Now, there's a couple more things I want to show you, which you can do. But let me just point out this one. All right. This is what I've done here. So I showed you how to use Burp to catch traffic from a virtual device running locally by adjusting the proxy to go through it. And that's one way to do it. That's easy, but it's fairly sloppy for a couple of reasons. The first thing is you have to have a virtual device. And although you can get virtual Android devices, I'm not aware of a virtual iOS device that works very well you can use. The next problem is not everything goes through that proxy. Some traffic just goes right past the proxy, right out, and you don't see it. There's a better way to do it, and this is what I found I could do like a few days ago, and I wrote it up for you here because this is wonderful. I take my Mac and connect it to the internet with Wi-Fi, and then I share Bluetooth out here, and the Mac has internet connection sharing. So I can turn it on, and now the Bluetooth phone can connect through the Mac and go up here. So now I really have a physical device in the middle, and you just share it here. With internet connection sharing, you can choose to share the Wi-Fi out the Bluetooth or many other combinations. One little gotcha is not all these work. And each version of iOS, they keep turning different ones on and off. So there's things you cannot do here and things you can do, but this one works. You can share the Wi-Fi out the Bluetooth. And I've done that here. So now you can connect a real device over Bluetooth to use it for the internet, and all the traffic goes through there, which is fine. But the problem is passing through the Mac is not enough. I want it to pass through Burp. So let me go down here a bit. There we go. All right. So you set up Burp as before, so it's just listening on all ports. And now what you got is you got Burp listening on port 8080. So now you have to tell your Android device to pass all traffic through 8080. And this turns out to be possible. I play around with a lot of things. There's something called IceFloor that's supposed to be a graphic interface for their firewall. I could not figure out how to get anything done with that. There's a very complicated firewall, which is the only one in the latest version of iOS called PF. And there are tutorials that made me cry, but this single thing I want to do here is in fact not too difficult. PF is vastly complicated and can break your heart, but if all you want to do is take all the traffic from one interface and send it to a port, that's not too hard. All you need is two files. You need pf.rules that contains this one rule. You find the name of the interface, which is this internet sharing interface, which is Bridge 100 in my case. You can just see which interface appears when you turn on internet sharing, and then you pass all ports to 127.0.0.1 port 8080. That's all you have to do. Now all the traffic on the Bluetooth connection goes through Burp. So you put in that rule, then you have a config file that just tells it where the rules file is, and you launch it with this thing, sudo pf control. This verifies the rule, this runs the rule, and now you can audit any real device, Android, Windows Phone, iOS, anything you want. Because it will just send the traffic through Burp, and you can watch it go by, and you can check for these invalid SSL certificates. So this is, and if you wanted to, by the way, Burp has the ability to create certificates on demand. So you could even make certificates with other kinds of errors if you wanted to. But if you don't, they're all going to have the missing CA error. So anyway, that's what I wanted to show you. And there's one more thing I want to show you that I have to turn this recording off for. So that's it for the recording. And I'm supposed to be able to stop it here. Stop.